Let's take a look at one more example. Let's rewrite f at x equals negative x squared plus 6x minus 2 using completing the square. Step 1, we'll start with the function f at x equals negative x squared plus 6x minus 2, and we'll move the negative 2 to the right. So now we have f at x is negative x squared plus 6x, and then a space, minus 2. Here what we do is we factor out negative 1 out of the first two terms, in much the same way as we factored a 2 out in the previous example. So if I factor a negative 1 out, that'll give me a positive x squared and a negative 6x. So I'll have negative 1 multiplied by the quantity x squared minus 6x plus blank, with the negative 2 at the end. Again, do not factor the negative out of the constant term. Now we complete the square on the first two terms of the expression inside the parentheses. So we'll take half of negative 6 and square it, which will give us 9. Right? Half of the x coefficient, and then square that. Now we add and subtract, but when we place the 9 in the parentheses, that net change is negative 9. Negative 1 multiplied by 9 gives me a negative 9. So to do the opposite, we will have to add 9 at the tail end. And so that'll give us f at x is negative 1 times x squared minus 6x plus 9, and then plus 7. Again, we factor the terms on the inside of the parentheses, and our final result is negative 1 multiplied by x minus 3 squared plus 7, which, yes, we could just write as the negative of x minus 3 squared plus 7.